projects. So, all right.
Hello, I'm Carson Wright, and I'll be presenting NDVI use in predicting Bermuda grass yields. I'd like to go ahead and thank Eric Messick, Tegan Crosswheat, the PhD student Jao Souza, and Dr. Brian Arnell, my mentor. So I'm studying NDVI, which is Normalized Difference Vegetation Index, and it is measured by optical sensor that measures reflectance by sending out bursts of red and infrared light and measuring how much is reflected off the plants, and then plugging that into a formula and giving you an NDVI reading, which is from 0 to 1, and 1 being like the most amount of reflectance you can get. And it's the near infrared that predicts more vegetation that's alive whenever it is reflected, and then the red that is reflected back is more stuff that's like not alive. And these tools have been used to help predict future Bermuda grass yield and some other things such as nitrogen uptake. The objective of my research is to investigate if NDVI can successfully be used to predict Bermuda grass yield and when would be best time to take NDVI measurements before harvesting. Here's the tool used, which is a Green Seeker NDVI tool. You can see on the figure 1, that's the top where it displays the measurement after you take it. And then the bottom has the sensors that you hold towards the ground. And then figures 3 and 4 are me and Eric out in the field taking measurements of our plots. So for the materials and methods, we were taking NDVI readings in 2 different fields that are right next to each other that are also being used for fertility and pH studies around Stillwater, Oklahoma. The fields combined had a total of 68 plots, which were 10 by 20 feet or 6.1 by 3.05 meters. And we were doing Bermuda, and it was first harvested on June 9th, and we cut it that day. We didn't use any of that in our data, but that was just to start with a fresh field. And then after that, we took NDVI measurements with the Green Seeker on June 25th, July 9th, and July 16th of this year. We take the NDVI measurements by walking one direction, like long ways across the plot, and then we write down that measurement, then we walk the other direction and take down another measurement. We average those together for each day we collected the data, where we have an average for each plot that day. And then at the end of the study, we harvested with a Carter harvester on July 23rd of this year, which we did lanes in each plot that were 3 by 20 feet or around 1 meter by 3 meters, or by 1 meter by 6 meters long for each plot we sampled. Then we collected the biomass yield by measuring how much we harvested in that plot. And then from the samples we collected from each plot, we took out some of the grass in that plot and submitted it to the SW FAL laboratory to analyze for moisture test. So if we go to our results, you can tell from June 25th, here's our NDVI for that day. This is the first reading we took, that compared to our dry yield, which was collected after we had the biomass yield, then we subtracted the amount that would have evaporated after we did the moisture analysis to where it's just the matter itself left without any water content. And for this day, the NDVI does not match up with the dry yield as good as it should be. There's a high R value. There's a negative correlation. In theory, this correlation should be positive in like a way, but it's too early for the reader to have an accurate reading. And if we go down here for the July 9th, it's still pretty muddy, the data overall, to where the line's still straight. There's a large R value, and this can kind of be explained later why this happens too. And then July 16th, we start getting a good correlation a week before cutting, to where there's a slightly higher R value that's still weak, but it's good. It shows there's definitely upward correlation overall in these values. And also one thing to mention is that you can tell the NDVI value between each of these days we collected data goes up from the first reading was 0.25 to 0.5. Then as the Bermuda grass continued grew, it was more like 0.55 to 0.75 on July 9th, and July 16th it went up slightly more. And then the dry yields overall are kind of not nearly as strong as the correlation compared to what we had for the biomass yields for each of these days. So I'm just going to show one of them, which was the best one for biomass yield. You can see here on July 16th, after we collected, the NDVI is really good at telling biomass yields overall. And we can kind of explain this by, as the biomass yields go up, the moisture percentage also goes up. So after you dry out the samples, the ones that weigh more immediately after you cut them will weigh like less overall, like a bigger difference compared to the biomass yields that are lower, which will lose slightly less moisture content once you dry it out and get the dry yield. That's the same. We've also realized that the NDVI, there's a correlation between that lower NDVI values have a lower moisture percentage compared to the higher ones, which can also correlate to a higher moisture percentage. And both of these last charts were done on July 6th. This is final yields, but this is NDVI from July 16th that we mastered moisture percentage. And then if you look over here, it gets a little bit more kind of confusing looking piecing it together, but you can tell as our dry yield weights decrease, our moisture percentage decreases, and then the lower dry weights have a higher moisture percentage, and the higher dry yields have a lower moisture percentage. So from this data right here, we include that NDVI is best able to predict biomass yield and dry yield on July 16th. NDVI was not good at predicting dry yield as it was predicting biomass yield. NDVI was good at predicting the moisture percentage during the harvest, and the biomass yield increased with moisture percentage. Thank you. And do you guys have any questions?